Hello everyone. Last time we have seen the problem based on analysis of DT system. We have seen how to find out the impulse response. Let us see more problem based on this analysis of DT system. So this problem was asked in May 17 for 10 marks. LTI system is described by the equation y of n is equal to this one. Determine the transfer function of the system and sketch the pole zero plot of the system in Z plane. Okay. So y of n will be given. The difference equation is given. We have to obtain the transfer function. So transfer functions obtained, we are taking the Z transform. Again here initial conditions are not given, and therefore we are assuming zero initial conditions. However, for obtaining transfer function, all initial condition must be zero. Okay, and therefore the while obtaining transfer function हमेशा आपको initial condition zero लेना है. Okay, so taking Z transform this difference equation, y of n का Z transform y of z, x of n having Z transform x of z, pointed as it is. X of n minus 1 has the Z transform z raised to minus 1 x of z, plus pointed z raised to minus 2 x of z, minus 0.49 z raised to minus 2 y of z. Then combine the terms of y of z on left hand side and combine the terms of x of z on right hand side. So terms is combined here, and then we'll obtain the transfer function y of z upon x of z. So this is the transfer function. Okay, h of z. System transfer function will be this one. In terms of negative power series of z, we'll obtain in terms of positive power series of z by multiplying z raised to minus 2. Z raised to minus 2 है यहाँ पे, तो we'll multiply numerator and denominator by z raised to plus 2, not minus 2. प्लस 2 से मल्टीप्लाई करते हैं न्यूमरेटर एंड डिनोमिनेटर को, तो ये टर्म मिलेगा आपको. तो z स्क्वायर, ये पॉइंटेड z बिकॉज एक z स्क्वायर से मल्टीप्लाई किया तो z रेस टू माइनस 1 एंड z रेस टू 2, उसमें से एक z कैंसिल हो जाएगा. ओके, हियर यू आर गेटिंग पॉइंटेड ओनली लाइक दिस. एंड देन इसका फैक्टराइज किया हम लोगों ने. रूट्स ऑफ न्यूमरेटर पॉलिनोमियल आर इक्वल टू जीरोस ऑफ द सिस्टम फंक्शन, and roots of denominator polynomial we equal to the poles of the system function. Okay, so these are the zeros and these two are the poles. So we'll draw the pole zero plot. In Z plane, zeros are represented by circle and poles are represented by cross sign. So there are two poles. One poles will be at minus 0.7j and second poles will be at plus 0.7j. So here is a plus 0.7j, here is a minus 0.7j, and there are two zeros. One is at z is equal to minus 0.4 minus 0.8j. So minus 0.4 and minus 0.8j will be this one. This is one zero represented by circle. Another zero will be minus 0.4 and plus 0.8j. This is another circle. Okay, isn't it? So these are the, we say that the two zeros, and this is pole zero plot of the system. Okay, the next problem is a system is described by the difference equation. A system is described by the difference equation, this one. Y of n is equal to 3 by 4, y of n minus 1 by y of n minus 2 plus x of n. Determine, first one, system transfer function, h of z. Second one, impulse response of the system. And third one is step response of the system. Okay. So to find out the transfer functions, we have to take the z transform of this equation. Okay, so y of n having the z transform y of z, y of n minus 1 having the z transform z raised to minus 1 y of z, y of n minus 2 having the z transform z raised to minus 2 y of z, x of n having the z transform x of z. Okay, then these two y terms we have to shift into the left hand side. Okay, and therefore the total terms of y of z will be this one and x of z. So system transfer function is y of z upon x of z. So y of z upon x of z is equal to 1 upon this term. So this is a system transfer function. Then you have to find out the impulse response. So impulse response of the system we can obtain from the output equation. Output of the system is y of z, which is equal to x of z into h of z. Okay, but since we have to obtain the impulse response, we have to find out the output, that is response for impulse input x of n must be equal to del n. So taking its z transform, x of z must be equal to 1 because the z transform del n is 1, and therefore y of z is equal to, you are getting h of z using this equation when you put x of z is equal to 1, and therefore y of z is equal to h of z, which is equal to this one. Okay, here again convert this into the positive power series of z and it will be like this. Okay, factorize the denominator polynomial. Okay, and you have to do the partial fraction expansion. Okay, so partial fraction expansion करना है इसका, तो एक z टर्म इधर लेना है. Okay, matlab you have to obtain the h of z upon z first, and then you have to do the partial fraction expansion. Okay, so it is a and b residue obtained kiya. Now you know that how to obtain this a and b residue. So a and b residues obtained kiya. The value of a will be 1, value of b will be -1. Okay, and then we'll put this value in h of z. We'll get the h of z upon z. H of z upon z is equal to a. A is what it is. Here is 1. So ये z इधर transfer किया था 1 into z upon z minus half. B is equal to -1. So -1 into z upon z minus 1 by 4, which is equal to this one. And then taking its inverse z transform, we are getting the impulse response h of n. So inverse z upon z minus a का inverse will be what it is, a raised to n u of n. Z upon z minus a का inverse will be a raised to n u of n. What is the z inverse z transform of z upon z minus a? It is a raised to n u of n. So इसका inverse z transform will be half raised to n u of n. इसका inverse z transform will be 1 by 4 raised to n u of n. This is the impulse response. Now if you want to find out the step response, you have to change the input. Okay, now this is the output equation of the system. Y of z is equal to x of z upon h of z. Using this output equation, we have to find out the output of the system when the input is u of n, that is step input. So take input x of n is equal to u of n. Taking its z transform u of n is z upon z minus 1. Okay, so ये equation जो है इसमें x of z का value ये put किया z upon z minus 1 and h of z का value already we know this is the value of h of z. Okay, again you have to combine this and obtain its inverse z transform. So y of z upon z is equal to what it is, z square upon z minus 1 by 4, z minus half and z minus 1. Okay, then you have to do the partial fraction expansion, obtain this 3 residue ABC 3 residues obtain करना है. Okay, तो a b c का value हम लोगों ने obtain किया. A is comes out to 1 by 3 and b is comes out to -2, c is comes out to be 8 by 3. and फिर ये इक्वेशन में पुट किया हम लोगों ने. ये z जो है ये साइड में मल्टीप्लाई कर देते हैं, इधर a b c लिखते हैं. व्हाट इज द वैल्यू ऑफ a इज 1 by 3 z upon z minus half, b is -2 into z upon z minus half, c is 8 by 3 into z upon z minus 1. And then taking its inverse z transform, we are getting the step response, which is also represented by s of n. So 1 by 3, 1 by 4 raised to n, then -2, half raised to n, 8 by 3, 1 raised to n. 1 raised to n is nothing but 1. So there is no need to here represent 1 raised to n. Okay. So this is a step response of the given system. Okay. The next we are going to see is stability in z domain. Okay. So we can define the stability in z domain in two ways. Okay. The first way is system is said to be stable if poles of the system are inside the unit circle. Okay. For example, this is a system transfer function. Okay. System is represented by its transfer function like this, z upon z minus half, z minus 1 by 4. So this is a circle of radius 1. Okay. And then we'll draw the two poles. One pole will be at 1 by 4, another poles will be at half. Okay. And it is seen that both the poles are inside the unit circle. Okay, दोनों भी पोल जो है यूनिट सर्कल के अंदर में हैं. तो अगर यूनिट सर्कल के अंदर में सब पोल्स आ रहे हैं तो सिस्टम इज स्टेबल, अदरवाइज सिस्टम इज अनस्टेबल. सो सिंस हियर बोथ द पोल्स आर इनसाइड द यूनिट सर्कल, सिस्टम इज स्टेबल. एक पोल इनसाइड में एक पोल आउटसाइड में तो सिस्टम इज अनस्टेबल. दोनों पोल आउटसाइड में तो सिस्टम इज अनस्टेबल लाइक दिस. ओके, सिस्टम इज ऑन दी, अगर पोल्स ऑन द यूनिट सर्कल है तो सिस्टम विल बी मार्जिनली स्टेबल. स्टेबल, मार्जिनली स्टेबल एंड अनस्टेबल, ऐसा है, isn't it? ऐसा है जेड प्लेन डिवाइड होता है व्हेन यू ड्रॉ द यूनिट सर्कल. इनसाइड द यूनिट सर्कल वाला रीजन स्टेबल. ओके, ऑन द सर्कल वाला रीजन विल बी मार्जिनली स्टेबल एंड आउटसाइड द सर्कल वाला रीजन विल बी अनस्टेबल. ओके, another way we can define the stability in terms of ROC. Okay, system is said to be stable if ROC region includes the unit circle. Okay, so ROC region में अगर unit circle 1 का circle आता है तो system will be stable, otherwise system is unstable. For example, let us say that the system transfer function will be this one, z upon z minus half, z minus 2. Okay, now if you consider the ROC region of the system is, अगर हम लोग ये ROC region कंसिडर करते हैं, दिस हैज द थ्री पॉसिबल ROC region. वन विल बी मॉड ऑफ z इज ग्रेटर देन 2, another will be mod of z is less than half, and third one will be mod of z is in between half and 2. Okay, so we'll draw this ROC. Okay, so we'll draw the two circle, one circle of radius half, another circle of radius 2. Okay, and दोनों के बीच में जो है that is the ROC region. So this is a ROC region, and this ROC region वन का सर्कल ड्रॉ कर रहे हैं हम लोग, तो सर्कल ऑफ रेडियस 1 will be this one. Okay, and circle of radius 1 are inside the unit circle, sorry, inside the ROC region. Okay, circle of radius 1 are inside the ROC region. ROC region में आ रहा है ये, बराबर है. वन का सर्कल ROC region में आ रहा है, तो वन का सर्कल अगर ROC region में आ रहा है तो सिस्टम इज स्टेबल. सो दिस सिस्टम इज स्टेबल. ओके, अगर वन का सर्कल जो है आउटसाइड द ROC region आता है तो सिस्टम इज अनस्टेबल. So in this way we can define the stability of the DT system in Z domain by using these two definitions, one in terms of poles and zero, another in terms of ROC condition. Thank you.